Hello and welcome again. In the previous video, we talked about a little bit about the inner structure of DES. And so if you remember what we did, it was something like this. So the ES is this box here that's going to take 64 bits of plain text and it's going to transform that into 64 bits of ciphertext. So it's a block cipher. Now, last time we talked about a little bit of the inner structure, and what that was is the following thing. So inside this box here, let's think about it as a box. We have a couple of things that are permutations. So this block here is what permutes this plain text that is coming in here. So we have 64 bits, and there is a way to permute or to rearrange this 64 bits using that table that I showed you in the last video. Similarly, we also had a permutation here at the end, which is the initial permutation inverse, which is also rearranging the 64 bits. And finally, what comes out of here is going to be the ciphertext. Of course, so we did this one last time, and remember that this initial permutation and this in final permutation here do not depend on the key. So the key doesn't play a role in this permutation. Now, as you can imagine, the real work of the DES is happening inside this box. So that's the real part, because here is where the key actually comes into place. So the key here will have the big role in the old DES. Remember that the key doesn't play a role in the initial permutation, and it doesn't play a role in this final permutation that we call the initial permutation inverse. So let's look at a little bit more detail at what this is. Okay, so the picture I'm gonna show you is like zoom in what this black box is in here. So let's zoom in that. So this picture that I have over here is the zoom in of that box, the one that we just saw over here. There's one over here. It's a zoom in. So let's go a little bit more in detail on what this one is. So, and I will explain this picture in detail now. So what's going to happen here is in that box, the key is going to play an important role there. And in that box, imagine you have other boxes. Each one of these boxes that is right here is called a round. And remember, we talked about this in previous video, and in the round we're gonna do confusion and diffusion. There are 16 rounds here inside that box. So what's happening here is you start with the first round, and then you go to the second round, and then you go to the third round, until finally you get to the last one, that's the 16th round. And after this, then this arrow that is here, this comes out to the initial permutation inverse. So what happens here in each round, so let's see, this round, this one, the third one, the fourth one, and so on until the last one, is confusion and diffusion, the one we talked about earlier. Now I'm gonna talk about a little bit what happens in each round, but for now let's just concentrate on what this is doing in general. So in general, we're doing confusion diffusion in all of those, and this part here is doing that on a 64-bit, because remember what happens here is you take a plain text of 64-bit, you put it in the initial permutation, you just rearrange those 64 bits, and when it comes in here, this is gonna be the first round. That first round is gonna transform those 64 bits into another 64 bits, which is this round right here. And then they go to the second round, and so on and so forth, until you get to the final round, which is 16. And as I mentioned earlier, this is where the key comes into place. Now, the key initially is 56 bits. I have 16 rounds. And what's going to happen is from this key, we're going to get 16 sub-keys. So one for each round. So each round is gonna use a different key. It's not gonna use the initial key. It's gonna use the sub keys that are coming from this key here, K. Now this process that you see here, having a key and getting some other keys from the original, is called what we call key schedule. So key schedule basically is you give me a key and I'm gonna produce another sequence of subkeys that are coming from this one. Now, there is a standard process on how you do this one, this key schedule, and we'll do that later. So, because if we do all in details, it will be very confusing. So let's go one by one, zooming one step at a time. So for now, you will have to believe me that there is a standard process that you take this is key of 56 bits and transform into this 16 subkeys, which each one of them is going to be 48 bits. So each key will go to one of the rounds. So for round 1, I'm going to use the key 1. From round 2, I'm going to use the key 2, and so on and so forth until I get to the last one. The 16th round is going to use the key that is the 16 that is coming from the original key. So that's basically the idea. That's how the key plays a role here in the big process of the DES. So what's going to happen here, as I mentioned, is going to be confusion, diffusion, and of course it's going to depend strongly on the key. Now, one thing that is important here is, as I mentioned there, that the subkeys that I have, the key schedule, generates 16 subkeys that all of them are 48 bits each. Okay, I haven't said what happens in each round, and I'm going to say that in a second in a little bit more detail. Now, what happens in round 1, which is this one, is going to be a little bit similar to what happens in round 2, what happens in round 3, and what happens in round 16. All these rounds have pretty much the same structure. Of course, they do different things in deep, because they're gonna use different keys basically for every round. So each key is gonna play an important role. Each subkey is gonna play an important role in every round. Okay, so now that we discussed a little bit about this, let's open this box here, this round, and see what this is. So let's zoom in into this one now. So what happens into that round? What happens into that round? What goes inside that round? Well, I have a 64 bit that is coming in here in this round. Why? Because if you go back here to my box, you'd have a 64 bit, do the permutation, and when this comes out of here, it's gonna go to the first round that is right there. So this first round that is right here, this one, and similar to the other ones, they're gonna act on a 64-bit block. And I'm gonna explain what happens in round 1, and actually that will give you a pretty good idea what's gonna happen in the other rounds, because they're all very similar. So let's look at round 1. So what happens in round 1? So let's look at that. So that's what I said already. What happens in round 1 is similar to what happens in all the other rounds 2 through 16. So what happens in round 1? So in round 1, that rectangle that I have over there represents my 64-bit block. Of course, this is all filled out with zeros and ones. So I have 64-bit here. So let me indicate that by marking this like this. So I have a line here, and I have 64 bits there. Now remember, this 64 bits is what comes out of the initial permutation. So this is already permuted. What round 1 is going to do is going to do a couple of things. The first thing it's going to do is the following thing. It's going to take that 64 bits and it's going to divide it into 2 equal parts. So right here through the middle. So let me see if I can just do it here to the middle. So it's going to divide it into 2 parts. The first 32 bits and the last 32 bits. So that's the first thing that round 1 is going to do. Round 2 is going to do exactly the same as round 3, as round 4. Is going to divide that block into 2 blocks of 32 bits each. Now you see there, we're going to introduce some notation as I go along here with this notation. You see I have a 32-bit on one side and a 32-bit here on the other side. I'm going to call this the left side, and I'm going to call this, of course, the right side. So I'm going to use the notation here. The left side, I'm going to call it L0. So this block here of 32 bits, this block here, I'm going to call that L0, the left hand side of that, the round 1. And this side here of this 32-bit, I'm going to call it R0 to indicate that's the right hand side. So L0 here, as I mentioned, represents this 32 block here. and this R0 represents this last one over here. So what's going to happen here after round 1 starts? So divides into 32 bits left and right. Let's just use this notation here, right? And what's going to happen here is it's going to transform, of course, in another 64-bit. So how is this going to happen? What's going to happen here is the following thing. Let's imagine again that the final result after that round is also like this. It's a 64-bit, and of course it's going to have 32 bits here and another 32 bits over here. The first operation is actually a very simple one, which is the following. The first round, what it's going to do is it's going to take this part here on the right, this 32 bits that are here, is going to copy that exactly into the left hand side of the 64-bit that comes out of that round. So let me indicate that with an arrow. So for example, what's going to happen here, let me use let's say another color. So I'm going to say that this round here, this 32-bit, is going to copy that exactly over here. So it's going to go all the way over here into these 32 bits right there. So nothing is going on there. There is no permutation, there is no sort, nothing like that. It's just an exact copy of the right hand side. Now, what happens after that? So what happens after that is that what the work that the round is going to do is basically what's going to happen to the left hand side. So the left hand side, basically what's going to happen here is the following thing. So this is where the key is going to come into place. So because this is round 1, I'm going to use my key 1. So key 1, let me use a color here. So key 1, let's say key 1 is going to come into here, the sub key 1 is going to come into this place over here. Okay, going to come here. It's going to come into here, to this place. I haven't completed the picture yet, so I'm going to give you the picture there. What this is going to do is the following thing. That key is going to go inside something that called the F function. The F function, I'm going to represent that with a box. And what is the structure of the F function? We're going to look at that later. So just imagine that that F function is actually the thing that is going to do the confusion and diffusion. So this is the main part of that structure there that I have here in the first round. Okay. So this function F is the one that is actually going to do the confusion and diffusion. Now, I already know half of my answer. Half of my answer is going to be here, which is exactly the right-hand side. So it's exactly this right-hand side. The next thing that's going to happen here is that function is going to act on the left-hand side in the following way. What's going to happen here is the following thing. So this F function, as I mentioned, is going to take the key, and also is going to take whatever is coming from R0. So let me use the same color here. So R0 will also go here into this F function. So the F function is going to take as input, is going to take the subkey K1 and also these 32 bits that are here from the right hand side of this part. So the key and the right hand side. Now this F function is going to do something with this bytes. Of course, this is remember this is a 48 bit, and this right hand side is a 32 bit. So maybe just let me put it over there. So let me just say, for example, this is a 48 bit that is coming from the key, and of course this is a 32 bit. And they all come inside the function f. Now the function f is going to do something with that. Now after the function f is done with that process, it's going to do something with the left hand side. So let me indicate that by drawing another arrow here. So what's going to happen here is this left hand side goes in here. Okay, I hope the picture is not too complicated for you. In here, then the output of that f function is gonna go there, and what you're gonna do is the following thing. You're gonna take those two, which is the output of that is gonna be a 32-bit for the f function. So in here, I'm gonna have an output of 32, and also the L0, of course, is a 32-bit because that's the left-hand side of this. Okay. So what's gonna happen here with this 32-bit? and this 32-bit that's coming out of the function f. What's going to happen there is I'm going to sort it, these two things. So let me indicate that with the symbol for sort. So I'm going to just put a circle there with a sort. Okay, that one. So I take again, I'm going to explain that again. So you take the right hand side here, you feed it into the f function, which I'll explain later, and goes in there, this 32-bit. The subkey k1 goes also into the f function. Now this f function is going to transform this right hand side 32-bit, and this subkey of 48 bits is going to transform that into a 32-bit that goes in here. The L0 that I haven't touched yet is going to be going into here in this to sort. This is the bitwise sort. Now once this is done, once you get the bitwise sort there, you're going to put those 32 bits, because this is what is coming in here. Also, this is a 32-bit. Oops, let me write that down, 32-bit. This is going to sort it, and then finally, this is going to put it on the right-hand side of that final block here. So this is going to happen over here. As you can see, of course, this is a little bit more complicated than the initial permutation and the final permutation, which is the inverse. But the idea is not very difficult. So if you're a little bit confused about this, just watch the video again, how the process goes, which is basically what I just said there. You take the right hand side, you put it exactly in the left hand side, and then this R0 will be copied here exactly as it is, R0. And the left hand side here is going to do something with this key in the right hand side that come into the f function, 32 bits and 48 bits into the f function. The f function takes those two things, those inputs, and outputs a 32-bit, and sort that with the left hand side of that initial 64 block and put it here on this side. Now that final result, we're gonna call that, let's just give it names again. Then we're gonna call this L1 because it's the left hand side, and this is gonna be the R1. So finally what happens here is that's the transformation. Now of course there are some things here that are missing. For example, what is this guy doing? The f function, that's the big part there. And actually the main part, the very big part of everything here is what this function does, because this is very understandable here. The sort function, we already know how that works. We also know that this here is just a copy here on the left hand side, and of course the big part here would be this f, and of course the sort here, which is sorting whatever the f is, the l is, and putting it back here into the right hand side. So once that is done, this is another 64-bit. That 64-bit will go into the second round. The second round will do almost exactly the same thing. It's gonna have exactly the same structure, but instead of using K1, it's gonna use K2, and instead of using R0, it's gonna use the R1. So I can keep going down here, but all this inner structure that is here is exactly the same for the next round. So this 64-bit that you see here, let me go back here to the picture. That 64-bit, the final bit, is what comes out of this round, and it puts it into the second round, and the second round has exactly the same structure as the first round. So that's basically what happens in every round. So in every round, what happens is almost exactly the same what happens here. The only difference is that the key is going to be different, right? And of course the R0 and the L0 are going to be different, because in every round, the 64 bits, every time they are changing. Now, I'll stop the video now, and so in the next video, I will explain a little bit more on notation, and hopefully then we'll explain a little bit more of what this function f here is doing. So I'll see you in the next video.